All right, we are back here to do more of this binary file deep dive project. As always, here's your reminder that this project is funded by people like you who think it's cool and would like to see it keep going, and go and check out mrforth.com/membership and decide that it'll be worth it to pitch in. And so if you were to do that, I would appreciate it a lot. But we can't spend all day looking at that. We got to get to this. So last time I was thinking that I would like to move on to these COFF relocations and actually get them working. But there are a lot of complications that come from COFF relocations now that really require a deeper refactor at this point. So I did a little planning in between the last stream and this stream, did a little thinking, and came up with this plan for how I would like things to work. This is not how things work right now. Right now, things are actually busted, super busted. So I'm about 10% of the way in to this refactor, and this refactor is ambitious. So it could be a while before it's working again. You can see it crashes when I try to run the generator right now. So what I'm going to do today is I just need to get into a groovy mode and work through the refactor. But before I do, I will give you a little bit of an idea of what I'm building here. So what I had previously was this idea that there was this layout and you were attaching data onto it, and the main thing you were attaching were the sections. You could also put pointers to certain subsections or certain ranges within those sections to these data directories. And then when you went to render it, the whole file, it would generate the header and put it all out. It used this file node stuff that I had made on like day one. We're at a point now where I realize that the main thing I need is to just render out a full block. So I've switched to this idea that I'll create my header itself as a block rather than rendering it out separately. I'll assemble the whole file as one big block, which is not how things were working before. And when I assemble it all as one big block, I can then render it into data and send it out to a file. Now there are some complications, right? One is, how am I going to get the header block? One is, how am I going to map virtual offsets from blocks? Another question is, now that this is happening, the layout idea is actually going to go away, and we're just going to have section lists, which will be good because now I'll be able to remove the requirement that I had before of needing to know the section count. Instead, what will happen is when you go to... Uh-oh. The programming candle just burned out. Okay, we're at the bottom of the programming candle. So I'm going to finish explaining the project, and I'm going to swap out the programming candle, and then we'll get into a groove. So now I can use the section list and get my virtual layout and the header block from that and go. And so if I want to say, hey, given all these sections that I've got plus an extra empty section, what would the virtual layout be, or something like that? And it can generate that, and then I can use that to do that, the base relocations, which was the whole reason why we needed to be able to incrementally build our layout in the first place. And so the idea here is to get to the point where we can incrementally build our layout without having to pre-declare the correct number of sections. So once we've done that, and we combine that with the ability to render from a full block, the idea we have left is that when we go to render a header, we need to know our section list. And when we do render our header, we get a block, and we get a virtual layout, which allow us to do patches. And then we have to apply all the patches to the data that we generate here. And we probably want to be able to just take that block as the root block and generate the data internally in this and fuse this in with this, ultimately. But there's a lot of steps in between. Where I'm actually at right now is I still have the layouts. I still have data sections. I now have this problem, which is the reason I needed to do this in the first place, that I want to be able to generate a lot more data that is not inside of a section than I used to. It used to just be the header, which didn't go through the block system. And then it became that and the symbol table, which did go through the block system, but couldn't be inside of a section. And now there's also COFF relocations, which want to be outside of sections. And so I'm just past the point where attaching things to sections is really working. The sections will be more of an additional piece of information that we use for rendering the header, but it is not really appropriate for the blocks and sections to be so intermingled the way they were before. Instead, we're going to do everything based on the data blocks, and then have this side data structure for mapping out things like sections and virtual offsets. The only piece that's still in that's a little funky is that we need to apply patches, and patches kind of create this bridge between blocks, because patches are pointers between one location in one block and another location in another block, and the layout of those blocks. We know the layout of the blocks once we have a final single block for the whole file. We know the file offset layout, but we still need to know the virtual layout, and so that piece is a little bit question marky, a little bit strange, but I can't fully figure out the right way to do that until I get closer with the code, because as I get closer with the code, it'll become clear what is and isn't viable at the low level. All right, Fear of Code, I like your comment. I might come back and comment on it myself, but I want to go switch out the programming candle so I can get into the refactor in a sec. So I will be back in 1 minute. There we go, fresh candle, and we're off. Let's okay. Fear of Code makes a comment about if I had to do this refactor in full object-oriented design, it wouldn't be any easier, and I completely agree. Refactors are, I think the only way to understand a refactorization is to understand what a factorization is, and a factorization is essentially an arrow breakdown. Right, so if I have x to y, and it turns out that when I look inside x to y, if I say, hey, how does x to y really work? And we find out that, well, actually what's going on is that there's this concept of a foo, and so we have like an x to foo and a y to foo, a foo to y, and that's really how that breaks down. And then you find out that actually what an x is that it's, you know, it's a couple of these things called bars and a list of, you know, who knows what else, integers, and a y is actually, you know, we keep zooming in and finding out what these things are, and a y is actually, you know, it's a list of integers and bars or whatever, and the foo itself is actually, I don't know, it's a list of integers, I don't know. It's something like this, right? Like we have factorization, and then we find out that what's going to happen is that there's a way to take a bar and a bar to a list of bars, and And that's going to explain how we get from that to there's going to be a list of bars. Is actually a list of int, right? Like, who knows, right? But when you keep breaking it down, this is your factorization of x to y, is the point. And to refactor something is to leave the original arrow, the top level problem in place, and to rearrange all the mappings you're relying on internally. That means you're changing the main code. Refactorization is not the rote stuff. We think of refactorization as anything IntelliSense could do, like the pulling out a function. That's the easy baby stuff, right? Real refactorization requires writing new code because it means you are changing how you factored your original arrow, and therefore you're changing the boundaries on what functions are responsible for what and how they compose. Now, let's put on some groovy music. Something without too much lyrics so I can concentrate. Okay. And let's get debugging. Okay, so something that has happened here is that the layout position used to give me an offset into the section, and now it doesn't. But the layout position used to actually make sense as a concept, and it also doesn't make sense as a concept anymore. Okay, so hold on. I don't want to jump ahead here. I was trying to wipe this out because I don't think that's appropriate anymore. That's about like tying it into the layout, and patches need to work right on the blocks. Right? I mean, that's not entirely true. We're still going to need a virtual layout in order to handle VOffs. And that's what the layout does. But the first step of applying a patch now should be to just figure out where the data is, which is relative to the input data, not to the layout anymore. Yeah, so the issue is, this is the code for calculating the offset of a given block, but it's tied in with this concept. It's tied in with this concept that we don't want. It should work just right on blocks. What we want to do something like this. So we go through the block. We look at its offset within its parent and add that in here until we get to the block ancestor. I think what I'm going to do is I'm going to separate this out and give result a default value of max U32. And then fill in the real result. Hello, Raiders. Hello. If you got questions, go ahead and send them, but I'm kind of in a groove doing some programming at the moment. Samuel asks, have you done the generator? Yeah, the generator is sort of working, although I'm in the middle of a big refactor today. The object file generator is super close, but I need to change how sections relate to data blocks. Okay. So we also need to refactor patches completely. So let's dig into that for a minute. Let's just leave it as val equals 0 for now. And we have to do a full refactor on patches eventually. But let's see if we can... Okay, so we can run without crashing. That's nice. Now, full refactor here. Patches were originally based on flags. I think that's not working. And the reason it's not working... Well... Take a look here. A patch can a patch can do things like point at a virtual offset or a virtual address or section number, and I implemented them as flags so that I could turn on and off different features, but really none of these go together. Like if I have section relative and vadder at the same time, it doesn't mean anything. It doesn't add up in a useful way to anything. So while they're kind of like flags, they're actually much more exclusive. It's like you either have no flags or one of these flags, and that's not a flag system, right? So the types, this is more like a set of types. And another factor here is that the types can be in different spaces. Sometimes I'm going to want file relative offsets. Sometimes I'm going to want virtual space offsets. And the block system isn't going to know anything about virtual offsets. While I'm at it, we're not even going to know anything about the layout target position yet. That's got to go. Right. This would be like U32. Well, we'll see. We'll see about that. Yeah. But the kinds of things we need to be able to do are grab the section number of the place we're pointing to, grab the section relative offset to the section we're pointing to, grab the virtual offset of the thing we're pointing to, grab the virtual address of the thing we're pointing to, grab the relative offset in virtual space, and we want to be able to do file offset and relative offset in file space. So I could do an enum for each of those, but we're running into another problem now, which is that the idea of virtual offsets is not generic. It is very specialized. And this block system is now kind of more fundamental than the layout stuff. And the patches kind of want to live at that same layer as the block system, right? If I wanted to, I guess I could say the patches are living at the level of the section list, kind of like there's a section list and a patch list. They get built together, and you really do have to apply the patches outside of the main block system. But there's a reason I don't like that, which is that attaching patches to the blocks without having to pass around a patch list would make a lot more sense. The patches kind of go with the data that's inside the block quite tightly, and so I kind of want to get to a point where the block itself contains its own patches, right? So if the block is going to contain its own patches, then the problem becomes that the patch referring to a virtual offset is kind of confusing, because blocks don't actually know anything about the virtual layout. The virtual layout gets figured out after all the blocks are assembled, mostly. It gets figured out right here when the last block, the header block itself, gets built. Here's an interesting question. Do you plan to make an assembly language to generate PE files after that? An assembly language has been on my mind, but it's not one of the primary things I'm worried about. We have not been digging into the actual architecture specific, like machine architecture specific stuff. Like, we're not doing x64 or ARM or anything like that. So I don't have any of the assembler stuff written yet, but writing an assembler and a disassembler would be a great research project. I think that would be cool. I think it would open up the door to thinking about non-textual assemblers, which would be really cool. But it's not a priority right now. I do have some plans for cool things we could do to generate object files and link them into an executable, and cool things we could do to modify the idea of linking so we could see better how our programs get linked, and we could then finally talk about how I have ideas for making the idea of loading in external code more rich. So all of those are possibilities, but I think those are higher priority than the assembly part right now, right? Generating machine code is sort of this assembler compiler space, and it's an interesting space, but I'm kind of focusing on a different slice of the pie. Okay, so the question is, how on earth am I going to assign a meaning to a patch? And the idea I had is a patch basically comes down to a pair of labels for the start and offset, for the position of the pointer and the position that we point to. Yeah, DL open in Linux or library load in Windows are both external code loading functions, and they arrange an image file into your process for you, as you know. But I wonder about things like what if I wanted to stick extra information in there that I could easily take advantage of from a C program without needing a new language, just a new default assumption about what might be in there and how to load it out, right? So if I were to, for instance, call load library or DL open and then look at that image myself in its loaded state and parse out more stuff, what could I do with that? What could I bake into the executable in the first place? And then what could I do with it in the runtime? It's an interesting question to me. Okay, so this is how we compute. This tells us the positions. All of this is basically, well, let's see. This is including things like which set of bits to modify. And these are how to calculate the value. And so if I were to just put a kind down right here, the only kinds I could do that don't refer to virtual address or virtual offset or section numbers or any of that stuff is relative and absolute, right? So I could do a relative version and an absolute version. But then the rest of the question is, what space do you want this thing in? How are you going to ask for things like section numbers and section relative offsets and so on and so on? And the point is there are all these different coordinate systems. And, you know, as I'm saying that, I'm realizing it's a huge ask to not have these built into the patch. It's just a huge ask. It would be cool if the block system was not just for arranging object files and binary files. But I don't know how the patch system could possibly be generic, because every single file type is going to have its own set of possible interesting coordinate systems between locations. And so maybe it should just be file system specific, the way you patch pointers. Right? It should be file type, file format specific. So if that's the case, then the easy solution here is to just go patch kind, and then the patch kinds we actually need are file absolute, file relative, virtual absolute, virtual relative, virtual address, section number, section offset. Right? And then we just are like, boop, there we go. There's our patch kind. Okay. Okay, this is still underway, the full refactor right here. We are now about to switch on the kind of the patch to calculate the value. Yeah, so if I wanted to make this generic, then I think this part here would need to get replaced with a data block, or even a function pointer and a data block or something. It'd be weird. Some kind of instruction on how to apply the patch, and then the apply patches might need to take the extra implementation details that come with this specific file type or something. It'd be a sloppy abstraction, the old school function pointer nonsense type of abstraction, which I'm not all jazzed about building one of those for no good reason, so we won't. Okay, file absolute means we calculate the target offset So that's just target off, but this one is target off minus patch off. Now, for the virtual absolute position, what I kind of have to do is I have to figure out how to take the block that I've got and map it to a virtual offset. Or I could calculate a file offset and then map that to a virtual offset. That could be fine. Either way, there's no guarantee that the mapping actually works. So how do we want to deal with that part? The ways I can think of are this. Slow way, we just scan through the sections, find a matching block. That's going to be hard because the blocks are hierarchical, so the block pointer we have doesn't necessarily know which section it's contained in, right, or which blocks it's contained in directly. You have to look at each section and scan through the tree on of blocks at each section to look for a hit. Option number 2 is we mark the blocks themselves so they map back to the sections properly, and we need some way to make sure that the default value of that does not map to a section, because by default blocks don't map to sections. Another option is to map the blocks to virtual offsets in a separate data structure. This would take a little bit of time to build, and it would also take time to write the code to build it. But then it doesn't have to be intrusive and built into the block. But I think the most straightforward way is to just get the file offset, the same way we're doing for other ones, and map the file offset through the layout to a virtual offset. Because we can optimize that pretty easily later. And that's a pretty reusable building block. Once you know a file offset and you can turn it into a virtual offset, you can run with that. So let's And of course, the goal is to get off of this layout, but we might switch in a virtual layout at some point. Nice. All right, so that code is running. We actually are applying patches. I wonder if it's working now. That might have been the last thing that wasn't going to work. I built the file out of blocks. Apply patches. Okay, it does actually parse successfully in this editor, this hex editor, hex viewer thing. If I run the linker. Right. Link gen. I gotta swap out the linker on my two computers, unfortunately. I have not built a system that does that automatically yet. Okay, so some things are off. Well, that can't be good. Pointer to symbol table timestamp. Pointer to symbol table, number of symbols. Pointer to symbol table is what, 67? How is that a C though? Oh, I'm looking at the wrong spot, yeah. 4, 3. Why is there a 7 there? So yeah, the issue appears to be that this is a 7. I don't know. I don't know what exactly that is. Okay, so right now, there's a 0 there. So the total size is 67. All right. When we flatten our data, at 67, I'm still getting zeros. Now what happens if I apply patches? All right, so we got data size. Is there some patch in here that is putting a 7 right into that? That doesn't make sense. 67 isn't even... I see the problem. Okay, so it's still wrong, but it's still putting a 1 right there. I don't know what that's about. Let's take a look again. We're now narrowing in on it. It's during the apply patches part. Position 67 is normal. Why is it setting a section number? Target offset is 60. It's trying to point at this, but why would it be doing that? This looks like my text section, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Something like that. Maybe something going wrong right here. Yeah, so this is giving me the correct block. So later, when we get this far, patch off only includes the base of the block position, not the patch positions dot offset. Okay. All right, that's the linker running right there. All right, success. So it's working again, which is cool. Let me go through and clean up a bunch of dead stuff. At least it's working to generate object files. I haven't rewritten the PE file part yet. All of this can go. All of this can go. This needs to stay. This contains information I still need. This can go. All of this can go. No, not all of this. All of this can go. Okay. Okay. So what's working so far is block to data is working. The new patches are working. I'm generating the block for the header and using that for the file, the object file now. What I don't have yet is I still have a layout from the old system. I need to switch to a section list. Okay. All right, so again, writing the header function. We don't have layouts anymore, so none of that exists. We should go straight into this part. Ooh. That's not the right spot. Okay, we put a header into the block. We said that. This is the section list. Okay, now we need to use a patch. Okay, so what we're trying to do is we're trying to use a patch to assign the symbol table F off. Okay. Okay, here's where I'm landing. I kind of need something like this. Right, but we don't have that yet. So we can't do that. We can't do that. The plan here in the new factorization is that when we generate the header, we'll also generate layout information there. The reason for deferring it to that point is so that we don't have to declare the number of sections up front. So we just build a loose section list. And when we want to know the layout of everything, we find out all at once with the whole section list. This has the advantage that I'm not declaring the count up front, but the disadvantage that I'm doing all of the layout as a baking pass together right here, and so it kind of has to go together with the header because some of that information gets baked into the header. So I think we need to go and build that part in order to actually lay out the sections in the file. We just don't know where sections go yet at this point. Similarly, we need to then change how we apply patches if we want to go that far. Okay. Oh, man. Okay, I'm going to take a short break. This is going to be a longer stream because I'm feeling like going a little hard on getting this working. But I need to take my 5-minute break. So I'm going to stop right here. Why don't we, let's see. Let's do it like this. Close panel. Okay, crashing. How did we get to that point? Whoops. There we go, non-crashing. Now, what we were just saying is we are gonna replace the idea of layout something a little more lightweight. I'm gonna just call it a V layout for now. Now we'll find out a little bit at a time, I think, what this really needs to include. Yeah, so the virtual layout's gonna be the replacement for layout. It really doesn't need to be a V. I'll call it layout later, but I need to distinguish it because I already have something called layout that's really major and I can't rip it out first. But we're trying to replace the idea of layout. So V layout's just the virtual layout, but I don't really need the separate name when I'm done. However, what it's going to contain is the entire layout of all the sections, both where they go in the file and where they go virtually in the image when the image is loaded, if that's relevant. And we won't know the layout until after we've run this part where we say, here's a section list, give me the block for the header that goes with it, because the header and the layout are tied together, right? The header contains data about the layout. So what I was doing before was I was building the layout incrementally and then building the header at the end. But one problem with that is building that incrementally requires you to know the size of the header up front. And to do that, you need to know the number of sections. So to get to a point where I don't need to know the number of sections up front, where I can build a section list API that just lets me build sections up freely, I need to be able to generate the layout along with the header instead of incrementally along the way. And so it's kind of a big change to not have it go along the way anymore. Okay, so we're going to have a block, name and a name size, flags. We won't need an F size, that'll just come with the block. Okay. Okay, so this mostly works. It's gonna be a little bit wrong because I still don't have relocations attached to sections, which we actually need. So what'll happen is when we do push section push, we might want a version that's like that, and also relocks or something like that, or we might take back the section here. I'm not sure yet. One way or another, we need to be able to set the relocations and use relocation block size as part of the walk here as well. I think the ultimate factorization of this is going to be you put in all the parameters and out pops a block. Well, you just put in all the parameters and out pops the file data. The factorization before that is the block that has collected everything up into the correct layout. The hard part here is that I've separated out the thing that assembles all the blocks into the correct layout and this bit. All right, so once we've done that, we have a V layout. So we can do section count sections plus I Now what I need to do is make sure these land in the right locations, you know? We didn't arrange... Yeah. Didn't arrange anything that would ensure the blocks actually have like alignment or offset that is enforced. But the section here does in fact know that important information about where things are supposed to go. So what I think I'm going to do is Patrick asked, "What purpose of deep dive what's the purpose of the deep dive into COFF? Are you doing some sort of debugger?" Not initially going to be a debugger. I'm going to make some cool tools though. We're going to learn a lot along the way and be able to do a lot of stuff. Part of the point is just to have all the basic code in place for enabling things like a debugger to be easier. So that's kind of accurate. But there's a lot of stuff we can do once we have a handle on the architecture for native layer software. So Okay. Okay, not quite right. Why is it off? The sections must be wrong. Ah, yep, here it is. Section table still needs to go down. Yeah, so why is that not coming out? Symbol table f off is supposed to be getting the f off from this patch, which points right to the beginning of the symbol table block. And the symbol table block then is supposed to be hanging out right here, getting pushed onto the file so that when... Oh, we're not applying patches anymore. That's the problem. Alright. Time for a new version of apply patches. We don't have a layout anymore, so it must be the layout from this guy that we need. hash list. Okay. So it looks like that worked again. Let's try and link. Okay. What are you talking about? This. Okay. Okay, so we're not running section offset. What are we doing that's leading to those that max U32? It's not there right now. Happens at hex position 80. So 80 is 16 times 8. It's 96 probably. Right there. When we apply patches, 96 didn't get filled. Oh, here it is. It's 128. 8 times 16. Oh, right. 8 times 6 is going to be bigger than a... Okay. So it ends up at 128 because 8 times 80 is 48. 6 times 8, right. Okay. So 128 just got filled with these. And that you're telling me that's not from applying a section offset patch? That seems like it's got to be a section offset patch. Okay, so you do come in here. The offset we're looking for. Ooh, that's not good. Why is the target offset like that? Was the target position in bad shape? The block is fine. Don't care. 1, 2. Okay. 1, 2. We come in here. Oh, so this can be a max U32 as well. So what just happened? The target position is this block. This block has no parent. And it's not the root block either. So what is that target position? Okay, the symbol position. How is it not in the layout? I don't know. The symbol position comes from symbol push. So we're talking about the text block, which is in this section. So it should be this one, which means it should be in the file, which means it should in fact resolve. Yeah, it's very strange. I need to look at the setup of the file block, I guess, because something isn't quite the way I think it should be. So this has a block of 0, huh? Yeah, looks like we missed that. My mistake. Wait, no, this isn't the one that fills the layout section. There it is, right there. The layout section comes from the section nodes block. So what about the section node then? Are we failing to fill that in? Oh, there it is. Yeah. That won't do it. Need this. Target offset now looks good. The section offset is still wrong. F offset of 120. Layout sections 1. F off goes from 0 to 7. My mistake. So there's a better way to do this, if I think about it. Just instead of having an F off cursor at all, we can just assign to the F off with a patch. Oh, we can't do that because this is a layout section, so it is not in the data block system. Interesting. And we actually need to be able to read off of it sooner, now that I think about it. Okay, so F off cursor needs to know the size of the header. Ah, okay. This part still sucks. But at least it's all bundled together now. This sucks all in one place. We gotta think about it again. Why this is not coming together quite nicely. Alright, so I think the f-off cursor needs to start with something like the size of a COFF header. Okay, so it's parsing that properly now. Machine, number of sections, time, date, symbol, pointer to symbol table. 43. Long name. Value, section number. Size of the table, some long name. And the link works again. And the dump works, and the program works. Okay, so we're back to working. I think this is a good place to stop. I mean, I'm definitely not done with the refactor, but there's just so much more to go, and we're a good 40 minutes over the usual 2-hour mark. So what I've got so far, if I think about it, is I think, yeah, I've got a bunch of dead code sitting around, so I'll need to go through and clean up a bit. Old apply patches can probably go. The old from layout stuff is gone, right? I still have a copy of... Yeah, this is the one with the DOS headers and stuff, so that's all good. We can lose the COFF one and the in-between one there. Layout VOFF from label, so all of that is fine. How are we doing? Can we get rid of layout now? So we can't quite get rid of it because we won't know how to replace this yet. So I think that's a good stopping point then. Definitely need to do more of this, possibly more of this off stream. But this is a long refactor, so having a spot where everything is working again is a nice... I'm way too far into the undo history here. Okay. Okay. So I think we'll wrap up there. I've got a lot more to do on this refactor still. So I don't know how much I'll do off stream and how much I'll be doing tomorrow. As a reminder, on Friday, I am going to be doing 4Coder Friday at my usual stream time. Where is... Here it is. So you can join me for that, 4Coder Friday, 10:30 a.m. Pacific time. We'll be reading more of the 4Coder codebase, and I'll be making comments about what I do and don't like about how I did 4Coder back in the day. And as a usual reminder, if you're watching this and you think these are cool projects I'm working on, the binary deep dive, the 4Coder Friday, plus I got other stuff going on in the background, arena resources and stuff like that. If you think these are cool projects and you'd like to help to keep the lab going, then consider going over to mrforth.com/membership, because I am counting on anyone who can to pitch in and become a supporter or a member. You can check out the cool features that come with the subscription. You can look at the yearly version or the monthly version. So yeah, think about it, and I'll see you all around the internet. Bye.